Okay, for the second half of class then, we're going to investigate the trig functions, the graphs of the trig functions. So you've got another worksheet here called Investigating Sketches of Trig Functions that looks very much like this. So very simple exercise. You're going to go to your calculator and ask to find the sine and cos of all the degrees, 0, 15, 30, and so forth, all the way down that list. Just punch it in your calculator. This is probably an exercise you did last year to get used to the shape of it. I want you to do it again, but notice that we're just keeping an eye on the radian measurements, because all the sketches we're going to do this semester or this year in grade 12, same sketches, but instead of talking degrees, we're going to talk radians. But first, let's remind ourselves of what it looks like. So we're going to do this. You're just going to go to your calculator and type in the sine of 0 and find out the 0. The sine of 15, 0.259. Sine of 30, 0.5. Sine of 45, 0.705, 707, excuse me. And then continue on and do all the rest of them. Once you've got all the sine values and the cosine values, flip your sheet over and do the sketches. So you'll see the top one is in degrees. So you can label your thing in degrees. And you'll notice that these are in increments of 15 degrees. Okay, so that means that if you're labeling this spot here is 15 degrees, this one is 30, this is another 15, so 45, this one's 60, this one's 75, and finally 90. 1, 2, 3, 4, 5, 6. Okay, so 15, 75, 90, and then 1, 2, 3, 4, 5, 6, you're at 180, and so forth. Notice that the y-axis are in increments of 0.25, so that means that this is 0.25. This one is an important one at 0.5, this one at 0.75, and then of course all the way up to 1. Same in the negative direction. Once you have this appropriately labeled, you're going to go back to your chart and sketch all these. So you see that it's 0 and 0. So we'll go 0 and 0. Next one, 15 and 0.259. So 15 and 0.259 is just up here. Okay, 30 and 0.5. There's 30 and 0.5, so I'm going to go back here, 30 and 0.5. Next one is 0.707, so just about here. Next one, 0.866, so just about here. Next one, 966, and then 1. Okay, so we have all these dots, and you're going to continue on this, and you should get a relatively good picture of what's going on with the sine curve. And then, of course, you're going to repeat all this with the cosine curve and start doing this. The cosine of 0 is 1, and then go off and fill in this chart. Okay, leave these ones blank for now. We'll come back to that. So take maybe 10 minutes, maybe 15 minutes to do that, and then I'll come back. You can pause the video, and I'll come back and take up what these pictures look like. Okay, so you should have a shape like this, and it should be very familiar. We see it's a sine curve. It starts here at 0, finishes at 360 degrees. We consider that one rotation, and you see it goes up and then down, and then it repeats itself, right? The highest point is at 90 degrees. It comes back to 0 at 180, and then it goes to its lowest point at 270, and so forth. There's certain characteristics that we should be very comfortable with in talking about this. Again, we're talking degrees right now. We'll make the jump to radians in a moment. But the characteristics, there are 3 zeros in this one. It starts at 0. Then at 180, it's back at 0. And at 360, it's back at 0. The max value is right up here. And that happens at 90 degrees and has a max value of 1. So the max value is 1 at 90 degrees. The minimum value happens over here, and it happens at 270. So the minimum value is -1 at 270 degrees. The y-intercept is where the graph begins, and I think we're comfortable with the sine curve starts at 1 or at 0, because the sine of 0 is 0. And then if you recall, we have these two terms to describe the function. So this is all from grade 11. We have something called the period and the amplitude. The period describes how long it takes to complete one cycle. So if we're talking in degrees, how long does it take to actually go through a complete cycle? So it starts here, it goes all the way up to its max point, comes all the way back down to 0, all the way down to its min point, and it completes one cycle here at the end at 360 degrees. So we say the period is 360 degrees, and then it repeats. The amplitude is how high or low the graph goes. So looking at here at this imaginary axis here, the amplitude describes how high or how low the wave goes. In this case, the amplitude is 1. This, we're not going to say -1 down here. It's just how far away is it from the axis. So the amplitude is 1. We understand that it's periodic, so it's going to continue. And if we look at it and we say it is positive in which quadrants? Well, if we were to label quadrants, from here to here is quadrant 1, between 0 and 90. Right? This is quadrant 1. And then we go from 90 to here. This is quadrant 2. So from here to here is quadrant 2. And then we've got, this is quadrant 3. And this is quadrant 4. What I'm curious about is when it's positive. Well, from the graph, you see it's all above the axis in the first two quadrants. Sorry, I'll just write that out better. So quadrant 1 and quadrant 2 is where this graph is positive. Well, what's this graph? This is the sine curve, right? Well, I already knew that from the CAST rule. C-A-S-P. Look where sine is positive. It's positive in the first quadrant and positive in the second quadrant. The graph confirms that. So that's all my conclusions on sine using degrees. This is everything from last year. So how does it look when we go off and do it with radians? Well, everything's the same, except you see my scale is just going to be different. So I haven't labeled the scale here just so that we can do it together. But you see in this case, this is in increments of pi over 12. We probably won't get as detailed as pi over 12. We'll probably just get as small as pi over 6. We're going to look at pi over 6 chunks. So every 6 things would be pi, every 6 ticks. Or you might go to quarters and do every 4 ticks would be pi. This one, just because I have a really accurate graph, I have it in pi over 12s, but we probably would just do in 6s. So there's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. 6 6 is just pi, 6 pi over 6. Or 180 degrees. And then we go off 7, 8, 9, 10, 11, and 12, which of course is 2 pi. So the good news is, it's just like the other graph. It's just instead of saying it goes between 0 and 360, it goes between 0 and 2 pi. Speaking of zeros, the zeros are all going to be the same, right? You start at 0, so we got 0. Then the next one, instead of at 180, it's at pi right here. And the last one is at the end where it comes back to 2 pi. Y-intercept's going to be exactly the same because it's not like this graph changes because we're in radians. It's the same shape. And all the y values are still the same. So the y-intercept is 0. So sine of theta in degrees is 0. It starts at 0. And sine of theta in radians starts in the same spot. It's just 0. And what's different? Well, the max value. The max value itself isn't different. It still only goes up to 1. But where we call that is a little bit different. So where is that? Well, we know it's 90 degrees. So we could just look at the graph above and see that it's 90 degrees. But how do we describe that? Well, it's halfway between 0 and pi. Well, halfway between that is called pi over 2. So the max value is still 1, still goes up to 1. But in radians, we say it happens at pi over 2 instead of 90 degrees. Min value, same thing. It goes all the way down to -1. Except where does that happen? Well, there's halfway between these two. So this is 2 pi over 2, and this is 4 pi over 2. So halfway between it must be 3 pi over 2. And really, these spots I really remember. Starts at 0, ends at 2 pi. Halfway it's back to at pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. So those spots are really important. Period. Okay, so now we have a new labeling for period. Before it was 360 degrees to do one cycle. Well, now in radians it's 2 pi to do one cycle. Amplitude, still the same. Goes up to 1 is the highest spot, down to -1, so its amplitude is 1. Notice again the y value doesn't change. It's just the x values are now in radians instead of degrees. And where is it positive? Well, the same thing. It's positive in quadrant 1 and quadrant 2. Okay, so I want you to be just as comfortable in describing the sine curve in radians as you are, hopefully, in describing it in degrees. Do the same thing, but I'll do the second one a lot quicker in cosine. The cosine curve starts at 1, goes down to -1, and then it comes back up to 1. So the zeros, there's only 2 of them. There's one here and here. So we see that it's at 90 and 270. Of course, we're starting by reviewing in degrees. The y-intercept, well, it starts at 1 as opposed to the cosine or the sine curve that starts at 0. What's the max value? Same thing. Max value is 1. And it happens at 0, or it happens again way down here at 360. The min value is right here, and it happens at, so it's at -1, but it happens at 180 degrees. Period. How long does it take to complete a cycle? Well, the cycle now starts at 1, goes all the way down through 0, down to -1, and all the way up through 0, and completes it right there. So the period is exactly the same as 360. Shouldn't be a surprise. And the amplitude, same thing. How tall is it? Well, in that case, it's 1. Now the question is, when is it positive? Well, if we look at the quadrants again, it's positive right here, which is the first quadrant. This is the second quadrant, and it's negative. The graph's down here. This is the third quadrant, and you see it's negative again. But then this final quadrant is it's back up in a positive. So it's positive in the first and fourth quadrant. Again, cast would have told me that. Where is cosine positive? Well, it's positive in down here and here, this being the first quadrant, this being the fourth. So it's good to know that the cast rule and the picture make sense, and making the connection between those is extremely important. What you'll need to get good at is not only remembering all that stuff in degrees, but now being able to describe it in radians. So again, where does this graph start? Well, it starts at 0. It finishes all the way down here at 2 pi. Halfway is pi. Halfway between these two is pi over 2. And halfway between these two is 3 pi over 2. So instead of saying the zeros are at 90 degrees, we would say pi over 2. Or 270, we would say 3 pi over 2. The y-intercept still is at 1. Max value still at 1, except it happens at 0. And again, repeats over here. The min value is halfway down It goes all the way down to -1, and it happens halfway through your cycle, which is at pi. Period instead of 360, it repeats every 2 pi, and the amplitude is still 1. And of course, the positive quadrants are still 1 and 4. So hopefully this has been a good reminder of what the graphs look like, and also a very good explanation on why we need to be able to do it in radians. So just as I expect this to be on the tip of your tongue and be ready for it whenever it happens, you should be able to draw the sketch right away as well. So if I come and ask you to find the sine curve and sketch it, okay, we should be able to just label it right away. So we'll go off and say, okay, sine curve. Pick a scale. I've got it. I'm going to pick 6s. So 1, 2, 3, 4, 5, 6. There's pi. 1, 2, 3, 4, 5, 6. There's 2 pi. Okay. Let's do quarters. So 1, 2, 3, 4. There we go. There's 1. 0.25, -1. And for the sine curve, I know it starts here, ends here. Halfway it's at 0. Halfway between these two is pi over 2. I don't necessarily need to label it, but it goes all the way up to its maximum. Halfway between these two is down to its minimum. And sketch. Boom. There's the sine curve. I should be able to do it, the cosine curve, just as easily. 1, 2, 3, 4, 5, 6. There's pi. 1, 2, 3, 4, 5, 6. There's 2 pi. Okay. Here's up at 1. Here's down at -1. Cosine curve, though, starts at 1 and ends at 1. Halfway between it's down at its minimum at -1. Halfway between 0 and pi is it crosses 0. Halfway between pi and 2 pi, it crosses at 0. And then we have our sketch. And there's y equals cos theta. So those two I expect to have right on the at my disposal at all times. Okay, good luck.